Hello everyone, this is your tutor AB, and today we're going to be solving a problem from the November 2020 IB examinations. This is a mathematics paper, Math AHL, and this is an additional higher level problem. This is paper 1. So let's get started. Find the equation of the tangent to the curve y is equal to e to the power of 2x minus 3x at the point where x is equal to 0. Now before I solve this question, let me just make you understand what is a tangent. Let's say your curve looks something like this and you want to find the tangent at this point. A tangent is nothing but the rate of change or the gradient at this particular point, right? It means that this gradient or line passes through this point and this point only. It doesn't touch the curve at any other point. That is what a tangent means. It looks something like this. Now this is just a rough sketch. I don't know if the graph actually looks like this, but this is what a tangent is. It's just a slope. So they're asking us to find the equation of the tangent to the curve. So an equation would be like y is equal to mx plus c, because the tangent is a straight line. Okay, so how do we find this? Well, to find a tangent, you want to differentiate. When you differentiate a curve or a curve's equation, you'll get the equation for its slope. So let's differentiate. D by dx of y gives us, and then we need to differentiate the right hand side. So this is just some addition. So we can say d by dx of e to the power of 2x minus 3. D by dx of 3x, which is just 3, so I won't differentiate that. I already know how to do it. So we get dy by dx is equal to, and remember, for anything e to the power of something, right, it's a chain rule. There's actually tables you can find for this on Google, but how you solve this type of thing is, the general rule for a e to the power of something is e to the power of x times x prime. That's the differentiation for e to the power of x. When you differentiate e to the power of x, you'll get it in this form. So let's use the same thing. So we'll get e to the power of 2x times 2, because 2x differentiated is 2 minus 3. Now further I'll get 2e to the power of 2x minus 3, and that is, right, this is the slope equation, the slope equation. Now we need to find what is the actual slope, and they've given us this point x is equal to 0. So let's substitute that into this equation. So dy by dx is equal to 2e to the power of 2 times 0 minus 3. So what does that give us? Dy by dx is equal to 2e to the power of 0, which would just be 2 minus 3, which is, well, 1, negative 1. So that is the slope. This is our m. This is the slope of our curve. We also need to find c, right? We found m and we need to find c. So how do we do this? Y is equal to mx plus c. When x is equal to 0, y is equal to what? That's what we need to find out. So to do that, let's substitute x is equal to 0 into this original equation. The original equation is y is equal to e to the power of 2x minus 3x. That's the original equation. So let's sub in 0 for x. So we'll get y is equal to, when I input 0 for x, what is the output? That output is y at this particular point, which is what we want to find the tangent for. So e to the power of 2 times 0 minus 3 times 0. So y is simply equal to e to the power of 0 minus 1. So y is equal to 1, right? Y, you get e to the power of 0, anything to the power of 0 is 1, and then 3 times 0 is 0, so y is equal to 1. So if we substitute all the values that we know, we can calculate for c. So 1 is equal to negative 1 times 0 plus c. Okay, so we get that c is equal to 1. Okay, that's our next part of the question. So all in all, if you put everything we know y is equal to m, which is negative 1x plus 1, or y is equal to negative x plus 1, and that is equation of tangent, of tangent. Okay, so I hope you guys have learned something, and I'll see you in the next video.